how to do a simple video editing. Okay, so first half an hours we are going to do discussions on the experiment. Second half we are going to do revisions on how to use video editing. Okay, I'll show you guys how to do video editing because it's very important. And for this experiment 5, what I want you guys to do is very simple. Other than report writing, I want you to practice to learn to do a video clip. Okay, which means you are going to do a short video clip for me. Okay, in between 1 to 3 minutes. I will tell you what is the things that you need to include in your video clip after this. All right, so but I want you to take note. Experiment 5, other than the report writing, I want you to do a video for me as well as a practice, as a test run, I would call. Okay, in case you got any things, for example, you don't know how to use the software, you don't know how to do the video editing, then at least you can ask in the group. We all can think about it together. All right, see how to solve the issues. So this week, we are going to take it as a test run. That's why I wanted to try a video. Okay, I wanted to try a video. So in case anything's happened, at least you still got time to fix it. Okay, now experiment 5 is a virtual lab. Don't look at the wrong lab manner, all right? So experiment 5 is a virtual lab. What are you going to do? You are going to do an experiment with the simple tools as usual. So experiment 5, simple harmonic motions. The learning outcome, remember, learning outcome is not objective. All right, still got students use it as objective in a report writing. So this is wrong. If you use it as an objective in a report writing, then you're going to get 0 mark in your objective. Okay, 0 mark for objective. So at the end of this lesson, students should be able to determine the accelerations due to gravity. So again, you're going to determine G. Okay, so if you're going to determine G, what does it mean? It means you have a theoretical value which is equals to 9.81 ms negative 2. So unlike experiment 4, I didn't give you the theoretical value. Why? Because it's a PDPR. And I don't know which flywheels they are using to generate that theoretical value. Okay, and I also don't know you're using which flywheel. So without knowing which flywheel, I cannot give you theoretical value. So experiment 4, basically you just comment on your result without comparing with the theoretical value. So you just state the results. All right. So in experiment 5, again, we are going back to G again. Therefore, G is equals to 9.81. You have the value. You need to do the comparisons. And then investigate the effect of large amplitude. Now, large amplitude oscillation, that is your second objective. You want to see what is the effect when you change the angle. So in this experiment, angle should be a constant value. All right. Why? Because you look at the theory. Now, what theory tells you? Theory tells you a simple harmonic motion, it comes with a few assumptions. First one, the simple pendulum bob is a point mass. Okay, you treat it as a point mass. You cannot treat it as an object with a large volume. Okay, and then the mass of the string is negligible. So what does it mean? It means in this experiment, you need to use a small, tiny string. Okay, very thin string. So in other words, you cannot use the nylon strings that you usually use to tie the things in your daily life. Okay, the pink color nylon string. That one is cannot. All right. So either you use the the strings, the fishing strings can, and then the strings that you use to sew your clothes and so on. Okay, for sewing. So that one is okay. All right, but the nylon string is cannot, because it's too thick, which will affect the oscillation. Okay, so you try to find some very thin string. And then that is the second assumption. The third assumption, the amplitude of the oscillation must be less than 10 degree. Okay, so which means you're going to make it at a fixed angle, less than 10 degree. So this is your protractor. Okay, this is your protractor. So protractor, usually there's a mark on top of it. Okay, so this is a horizontal line, this is a vertical line that represents 90 degree. Now, how you measure the angle? You put the string at this point. This is the point what I'm going to call it origin. Okay, so you put the string at this point, and then the angles beside the string, in between strings. Okay, this is a pendulum bob. In between string and the vertical line should be less than 10 degree. Okay, that is the meaning. That is the assumption. That is the things that within the obeys in a simple harmonic motion. Why? Because in simple harmonic motion, okay, if your angle is less than 10 degree, so what is going on? We assume your object is moving in a straight line. Okay, and our equation in chapter 9, they are all being derived based on the assumption where your object is moving in straight line from from the vertical line until its current position that is less than 10 degree. Okay, so that is an assumption. So you're going to see what happened if you conduct this experiment at an angle that is larger than 10 degree. Right? So that is our second objective. So theory, we are done with the assumption. So according to the theory, the period of oscillation, now you have the equations t equals to 2 pi square root L over G. This one is derived based on assumption where angle is less than 10 degree. Okay, so this equation is being derived based on the assumption that you're using a very, very small angles, that the object is moving in straight line from a vertical to a point that is less than 10 degree. Okay, that's why our equation is valid for less than 10 degree. But what happens if more than 10 degree? That is our objective. So rearrange equations. Now you obtain t square equals to 4 pi square L over G. Okay, so you have an equation. Now, why do we want to rearrange it? That is because the questions, the lab manual asks us to plot the graph of t square against L. So we need t square on the left-hand side and we need L on the right-hand side. So this might happen in your actual report writing test, okay, where it gives you equations 3.6, then you have to rearrange it to equations 3.7. It might happen. Okay, I cannot guarantee it happens or not. I cannot tell you it happens or not. Okay, because it's a brand new experiment. So what I can do right now is I tell you the possibility. So the possibility is you might get an equation like 3.6, but you yourself need to rearrange it into 3.7 based on the graph that it asks you to sketch. Okay, so it asks you to sketch t square against L, means that you must have t square on the left-hand side and L on the right-hand side. Okay, so that you can do comparisons with y equals to mx plus c. Okay, why? Because now your y-axis, according to the equations, the graph that it asks you to sketch, your y-axis is t square and your x-axis is L. Okay, so you need to rearrange it so that y and x, okay, is t square and L. And then by comparison, okay, the graph of the gradient of the graph is equals to the values of the g. Okay, you can use it to determine the values of the g. Okay, so the value of the g can be calculated from the gradient of the graph. Because when you compare with y equals to mx plus c, the remaining terms represent your m. Okay, the remaining terms represent m. So list of apparatus, a piece of string or threads. Now you just need a piece of string. So even though in the experiment, you need to use the length of the string start from 40, 50 up until 100. But then you just need a piece of a string that is approximately equal to 105 cm. Now why 105? 5 cm is for you to tie the string, because you need to tie it on the nail or something like that. Depends on the tools that you're using. All right. And then the 100 cm is for the actual length. So why one piece of string? Now, if you look at the setup of the apparatus, this is how you're going to do the experiment. Now, you shouldn't put the protractor on the wall. You cannot conduct this experiment on the wall. Why? Because this a pendulum, or we say this a padlock or keychain or anything that you use to act as a pendulum. Okay, if it is in contact with the wall, if it is touching the wall, then this experiment will become invalid. Okay, because it will give you an external frictional force. So external force will slow down the simple harmonic motion. Therefore, this experiment will become invalid. So how to conduct these experiments? So you need to find somewhere maybe it's high enough, or maybe you can do it at the edge of table if the table is high enough. Okay, so you need something that is just a piece of wood. Okay, then you can put your protractor here. Okay, you can put a protractor here and then hang your pendulum box here. And this area behind this pendulum box is empty. So meaning that this pendulum box, it won't touch anything. Okay, it won't touch anything, because one is touching the wall, then the whole experiment will becomes invalid, will be wrong. Okay, because it's no longer a simple harmonic motion. So you're giving it an external force, which is a friction, and friction will cause energy loss. Therefore, the whole experiment becomes invalid. So if you look at the list of apparatus, a piece of string, so you just need a piece. So after you tied it, if you got an additional length, then maybe you can just put it on top of the rack. All right, just make sure the additional string, okay, this additional part, the remaining string, all right, remaining string, it won't interfere with the oscillation. All right, so a piece of a string, and then a padlock or a keychain or anything that is heavy but small and can be hung. Okay, heavy but small, because you need to make sure you have a nice smooth oscillation. So if you tie something that is too light here, then maybe it cannot swing nicely. All right, it cannot swing nicely. So you need something heavy but small. So padlock is the best thing to use. If you don't have padlock, then you try to find something that is a bit heavy. Okay, a bit heavy, that can make sure your string move in a straight line. And then a suitable place to hang the pendulum, like I told you just now, perhaps a rack, okay, or maybe it's a table edge, but just make sure your table is high enough. And then a stopwatch or a stopwatch function in a smartphone. So again, you need a stopwatch, so you can use a spot stopwatch or you use a smartphone stopwatch. A meter ruler, okay, for you to measure the string, okay, for you to measure the string. And then a protractor with a hole at the center. Now this hole, actually it represents the place that I showed you just now, okay, the blue color dot, because that is the origin. Okay, that is the origin. So your string need to start from here, otherwise you cannot get a correct angle. Okay, if it doesn't put it here, then the angle would be wrong. Right, that's why it asks you to put a hole. Because why? Because in an actual experiment in a lab, there's a hole here, then you put a nail. So you just tie the string on the nail. Okay, but in your house, if you don't want to make a hole, then maybe perhaps you can use a plasticine, okay, or you can use anything else. Okay, anything that you think is suitable. All right. And then a pair of scissors, okay, that is up to you. What is the apparatus that you want to use to cut the string? So the setup is very simple. Okay, the setup is exactly as be shown in the diagram. So you just think, how are you going to set it up? Okay, and then, okay, step number one. Step number one, set up the simple pendulum as shown in the figure 3.3. Take pictures of your complete setup and attach it in your lab report. So meaning that you don't have to sketch the diagram. And in fact, you don't have to do a diagram, do the procedure. Why? Because I want you to do it like how you did the experiment 4. Okay, we follow exam format. Okay, we try to practice exam format. See whether you can finish the whole report writing within an hour or not. All right, because in your report writing test, you'll be given times 1 hour. So we try to practice, see whether you can finish everything in 1 hour or not. All right. So set up a simple pendulum as shown in figure 3. So make sure you take a picture. So the picture, you need to show me the whole setup, including how you tie the string. Okay, I want to see how you tie the string. And then measures the length of a string's about 40 cm. Okay, about 40 cm. And then release the pendulum at a place that is 10 degrees from the, less than 10 degrees from the vertical. So just now you have this, okay, you have it here. So this is a horizontal line, and then 90 degrees, this is the mark. So make sure you release it at a place that is less than 10 degrees. Okay, and then record the time for 10 oscillation. Now, what is the meanings of oscillation? Okay, now you release, let's say you release the pendulum bob at here. Okay, at this position, so I'm going to call it positions A. After you release it, it will swing back to its original position, what I'm going to call it positions B. And then it goes to the 10 degree on the other direction, okay, at the opposite side. I'm going to call it position C. And now when it reaches position C, which is the highest point of the place that it can reach, it will then goes back to B. Okay, and from B, it will then swings back to A. So from A to B to C, and then goes back to B and to A again. Okay, one complete set, we call it one oscillation. Okay, so this is one oscillation, one complete set from A to B to C, and then go back to B, go back to A. All right. So this is how you record the time. But make sure if you read the lab manual again, it tells you what? It tells you start the stopwatch after several complete oscillation. Why? Because the moment you release it, the first 2 or 3 oscillation is not smooth yet. Okay, it's still adjusting its speed. Okay, it's still trying to speed up from 0 from the moment that you release it. Okay, try to speed up, try to swing. So don't record the time. Don't start your stopwatch right after you drop it, you release the pendulum bob. You start your stopwatch after it oscillate maybe 2 or 3 cycles. Okay, so whole experiment, maybe you need it to swing like 15 cycles, for example. You wait for 5 oscillation first before you start to record the time. Okay, that is example. So at least 2 to 3 oscillation. You let it oscillate until it's smooth already, then you start your stopwatch. Okay, and the moment you start your stopwatch, you start to do the counting. I want to see the counting in your video. You can count by using text or you can count with your voice. All right, count 10 oscillation and then you stop the stopwatch. Okay, so in your video, you need to show you start the stopwatch and then you stop the stopwatch. All right. So start the stopwatch after several complete oscillations, and then you record the times taken for 10 oscillation. And then what happened next? What happened next? It asks you to calculate the period of oscillation. So if you recall the things that we learned in our lecture, what is the difference between small letter t and capital letter T? Small letter t is the time taken, okay, time taken for any amount of oscillation. Okay, so for example, just now you have 10 oscillation. So small letter t, you record the time taken for 10 oscillation. And then you calculate the time taken for 1 oscillation. That is what we call period. Okay, so from 10 oscillations, how are you going to calculate the time for all 1 oscillation? That one, I leave it to you. That is simple mathematics. All right, just remember, step number 4, you need to calculate something called period. So you calculate the time taken for 1 oscillation from the times that you record in step number 3. Okay, so then calculate the periods of oscillations of the pendulum. And then you repeat step number 4 for 50 cm, 60, 70, 80, 90. But like I told you, you just need 1 string. Okay, 1 string is enough. So you just tie it to the pendulums or to the protractor. And then the additional part, maybe you can tie it somewhere else or you can put it on top of the rack, as long as it don't interfere with the oscillation. All right. Now, how to measure the length? Okay, now, this is your protractor again. Okay, so this is the origin. Then you tie a string. Okay, you tie your pendulum bob. So the 40 cm, 50 cm and everything is starting from this dot. Okay, starting from this point. So make sure after you tied it, you measure it again. Because usually the mistake that happen, okay, the mistake that happen is the students measure it first and then tied it to the nail. When you tied it, maybe you do a few rounds. Okay, you curl a few rounds, you whirl a few rounds around the nail. Then your length will become shorter. Then L would be less than 40, 50, 60, 70, 80, and 90. All right, then that is wrong. So what you have to do, you need to measure the string again after you tied it to ensure that the length is exactly the length that you want. For example, 40 cm. Okay, 40 cm. So repeat step 3 and 4 to get readings, the T for 50, 60, 70, 80, and 90. So altogether, you have 6 sets of reading, including 40 cm. Okay, and then plot the graph of T square against L. From the gradients of the graph, you determine G. So this is first G. This experiment, you need to measure a few G. Okay, this is first G. So you need another G from 70 degrees. So I'm going to mark an N line here. Okay, so that is the first part of the experiment. So what happened next? Next, you repeat the experiment again. Okay, you repeat the experiment again. Now you're going to use 100 cm length, and then you release the pendulum through a 70-degree now. Okay, now you want to release at a 70-degree. So in a 70-degree, you can no longer assume your pendulum bob is moving in a straight line. Now it's moving in an arc, okay, a curve. And in this step, you just record the time for 5 complete oscillation. Then you repeat it and get average value. So again, you need average value for all of the experiment. All right. And then calculate the period of oscillation. Again, you calculate period. But what happened in this second part of experiment, you don't need graph anymore. Okay, because you just have one length and then one time, one period. Straight away, you calculate it by using equation from 3.1. Okay, so this is your second G, second accelerations due to gravity. So which means you have two different G that you obtain from the experiment. Okay, you obtain 2G, and then you compare both of them with standard value, which is G equals to 9.81, ms negative 2. Right? So you have two set of data. First, G from graph. Okay, G from a gradient. Then you calculate the percentage of a difference. And then G from G from equations. Okay, G from equations, and then you calculate the percentage of difference. Right? So basically it's G for 10-degree and G for 70-degree. You can also call it like that. So it's up to you how you name it. Okay, that one I don't care. What I want to see is your result, is your calculations. So G for step number 7, G for step number 9, then you have 2 percentage of difference, then you compare. So first one, okay, first objective, you just need the G from the first part of the experiment, from the gradient. Okay, you use the 10-degree. And then the second objective, you do the comparisons between first and the second G that you obtain from the experiment. All right, see which one give you less percentage of difference. The one with lesser percentage of difference means it's more accurate. All right, and by theory, 10-degree should get a smaller percentage of difference. Okay, that is by theory. Because from a 70-degree, object is no longer moving in a straight line, and therefore the equation is actually invalid. Okay, the equation that we use is invalid. So when the equation is invalid, then it should give you a larger percentage of difference. All right, so 2G, 1G from step number 7, where you use it to answer objective 1, and then another G from step number 9, where you use it to compare with step number 7G, and then from there you determine whether amplitude, the degree of an amplitude affect the readings or not. Okay, whether angle affects the readings or not. Okay, so done. That is the end of the experiment. Okay, so it's a very simple experiment. So remember how to write your report. Start from title, and then objective, and then observation. Observations. So what you need to include in your observation? Table, calculations. Okay, so what do you need to include in your calculations again? Centroid. Okay, so you need centroid, and then gradient, and then required value, which is a G. Okay, required values. And then another thing that you need to include is a graph. So 3 things in your observation, and then your discussion. So discussions now is no longer 3 paragraph, but 4 paragraph. Okay, remember, because of a report writing test, now we have to change it into 4 paragraph. So which 4th paragraph? First paragraph, you comment and compare. Okay, comment and compare. So compare between 2 different G, compare between the G that you obtain with the theoretical value. That is what we say compare. Okay, and then second paragraph, 1 precaution. So remember, precaution is the step, is the actions that have been taken before you start the experiment. Okay, and then third paragraph, 2 errors. 4th paragraph, 2 suggestions. Okay, suggestion must be related to error, must be based on error. So you're going to tell the reader, now you have done this experiment, you have observed two unavoidable errors. So you try to give a suggestions. What you should do, okay? What should you do if you're going to repeat this experiment again to overcome the error that you observe in this experiment? All right. So error is something that happens when you conduct the experiment, not before you do the experiment. Okay. Before, don't say before you do an experiment, you already know what is going on. Okay, what is the error? No. So it is something that will happen throughout the experiment. Right? So two error, two suggestions. Okay, so the things, the actions that have been taken before you do the experiment is called precaution. Usually that is the things that you like to say is switch off the fan. So that one is your precaution. That one is not your suggestions. Okay, suggestion is some things that you cannot overcome when you do the experiment today. Okay, for example, you want to conduct the experiment later tonight. When you do the experiment, you cannot fix it on the spot. You cannot overcome that error on the spot. Okay, then you give suggestions. If you're going to repeat it again, what is the additional step that should be taken to overcome the error, right? So precaution, for example, switch off the fan. Switch off the fan, you can switch it off immediately. So that one is not suggestions. Okay, that one is precaution. So make sure you know the difference. Okay, so previously I accept either you give me suggestions or precautions, but now it's no longer being accepted. You need to do it according to your report writing test requirement. Right. So after discussion, then conclusions. Again, conclusion just refers to the objective and then answer your objective. Okay, so that marks the end of experiment 5. Okay, I think it shouldn't be an issue for you because it's a very simple experiment and it doesn't involve a lot of technology. Okay, like your experiment freeform motion. Okay, now one more thing. Okay, talk about technology. In case your house is in a Fasa 1 zone and the bookshop has not opened yet, okay, then you don't have protector. What can you do? You can actually search for the apps. Okay, there are plenty of apps that can be used and it can be used as a protector. Okay, when you install the apps, then you can see a protector on the screen. You can use that one. That's fine. Okay, if you don't have an actual protector with you, then you can use a virtual one, which can be found in the apps. Okay, just that you have to go and look for the apps. Okay, I don't know which apps can be used, so you try to find it. Okay, you find it by yourself. So we're done with virtual lab. So far, any experiment? I've walked you through on how to conduct the experiment, the do and don'ts in the experiment. So do you have any questions? Ada tak sebarang pertanyaan, persoalan mengenai eksperimen ini? Sebab ini eksperimen yang kamu kena buat minggu ini. No question? Okay, good. So I don't want you to do a same mistake again like you did in your experiment 2, yeah? Make sure pendulum bob is far away from the wall. Okay. So virtual lab done. Let's look at pre-lab. So pre-lab is just very simple. I will go through it quickly. I'm going to finish it within 5 minutes so that I can show you how to do the video. Okay, now experiment 5, simple harmonic motion. All this, I'm going to skip it. So what is a simple pendulum? Simple pendulum is one of which can be considered as point mass. Okay, and is suspended from a string of a rod of negligible mass. Now, the motions that return to its initial positions, we call it periodic motion. So a simple harmonic motion, SHM, is a form of periodic motion because it keeps swinging back and forth. Okay, it keeps going back to its initial position. So instead, two quantity that is proportional to the object displacement. One is accelerations and one is restoring force. Now, this one, I will keep it in lecture. Okay, so you just write down the answer first. It's a chapter 9 lecture. And then the condition, this condition just now we discussed already, is in your theory. First, you assume the mass is a point mass. Second, you assume that the mass of the string is negligible. And then at last, the angle must be less than 10 degrees. And then the next one, again, I will keep it in a lecture. Okay, I'll keep it for lecture because number 3 and number 5, you need the background knowledge in order to answer these two questions. But we haven't reached this part yet in our class. All right, so I'm going to skip it. Now let's go to the experiment. Okay, number 6, I'll skip it. I want you to think. Okay, number 7, if we vary the length of the pendulum, so what is going to happen? Now this table is a bit incorrect. Okay, I will modify it a bit. You need to include it here. 1, 2, 3, and then this one is your average. Okay, so the uncertainty depends on your device. All right, it depends on your device. So how many decimal places to use? If you forgot already, you may refer your previous practical class video. All right, I shows you how to determine the uncertainty, especially for average time in your previous video clip, in your previous class. So if you already forgotten, then you may go through the video again. Okay, video is in YouTube and it will be there until the end of the SEM. Okay, I will leave it until the end of the SEM, so you can keep rewatching it if there's anything that you don't understand. So you have a length, and then you have the times, you have a period, and then period square. Okay, so you need to do two tables, one for 10 degree, the second table is for 70 degree. All right, two table, one for 10 degree, the second table is for 10 degree and 70 degree. And then what is the title of the graph? So it asks you to plot t square against L, so definitely this is your title of the graph. And now which procedure that investigate the effect of large amplitude? State the related angle used. So we use a 70 degree, step number 7. Okay, we use it to investigate what happened when you use a large amplitude. So how to determine the values of G is by comparison. Compare the equations in 3.2 with the y equals to mx plus c. Okay, and then calculate the percentage of difference. So you don't calculate the percentage of error, you calculate the percentage of difference. Percentage of difference is the difference between experimental value and the theoretical value. Percentage of error, you calculate the percentage of delta G. But in this experiment, we don't ask you to calculate delta G, therefore you can skip it. Okay, what you need is just percentage of difference. Predict what will happen if you use a large amplitude, then the path is no longer a linear path. All right, that is the answer. Okay, that is the answer. So precautions, all those things I will leave it to you. Precautions and suggestions, I'm not going to discuss with you. All right, so that marks the end of pre-lab. So pre-lab is very simple. Okay, pre-lab is very simple, nothing much to see. All right, so now I give you 2 minutes break. Okay, after 2 minutes, we are going to go through a video. Okay, we are going to see how to do a video. So 2 minutes break, we'll continue again at 12:35. Okay, so let us see how to do a simple video editing. So the reasons why I recommend to use a built-in editor in your Windows 10 is because it's free first, and then the second thing is because it doesn't come with watermark. Now, in your practical test, if you use online software, of course you can, okay, you can use online software. You need to make sure the watermark, it doesn't cover up any important information. Because some watermark, it comes out at the bottoms, at the corner, that is fine, but some of them, they put it at the middles of the video. So if you use all those software with watermarks, then you have to make sure it doesn't cover up any of the important information in your video. All right. So now let's see. So if in order to use the video editor, you go to the search. Okay, you type here to search, and then you type, okay, video editor. So it will comes up. So this is the apps that we're going to use. All right. So you go to video editor. Okay, so it will brings up a new window. Okay, so wait, yeah, it's a bit slow because I got plenty of project here. Okay, now it will brings up a window like this. Okay, so here, welcome back to video editor. So what are you going to do? You're going to start a new video project. So you click on a new video project. Okay, just wait for a moment. All right. So after you start a new video project, it will bring you to a new panel like this. This is where we want to edit our video. Okay, so take a bit of time because it will ask you to key in the name. So once you key in the names of your video, then we are done. Okay, that means we are ready to create a video. Okay, so it takes a bit of time to load. Okay. Yeah, it's a bit slow, my PC. Okay, let me restart it. I think it's a bit stuck. Yeah, let me refresh it first. Okay. Okay, so now I'm going to start a new project. So new project, it brings up a new panel like this. So when you're starting a new video, it will ask you to key in the name. Okay, it will ask you to name your video. So name your video. What I want you to do, you key in your name first. So for example, my name, okay, you, and then underscore. Okay, underscore, and what I want you to put, okay, I want you to put in your metric number. Okay, so this is what you're going to do in your practical test as well. Okay, I want you to write your name, your video's name in this form. Your full name, underscore your metric number. Okay, and then okay. So the names will comes up on the top left corner, so you can see whether that is correct. Now, okay, once you name the video, means that you are ready. Okay, you are ready to use the video editor to edit your video. So how to edit the video? You go to add. Okay, you go to add. You can add from PC. You can add from your picture collections. You can add from the web. Usually I add from PC. Okay, so add from PC. Now I have a few picture here, and then together with a video clip. Okay, so you can record multiple video clip and then combine them. That is fine. Okay, you don't have to finish everything in one shot. So let's say now I have taken a few photo. Okay, so I want to select the photo. Now you just select one and then press the Control key on the keyboard. Select the second photo, third photo, the fourth photo. Okay, so maybe I want two video clip. One video clip, two video clip. And then you open. When you open, okay, the video and the pictures that you select, it will comes up in this project library. Okay, so this project library, you have all video clips, the pictures that you want to put in your video. Okay, now after you're done with the project library, what are you going to do? Let's say now this is my front page. So I drag it down. Just drag and drop. Okay, drag and drop concept. You drag it from library, you drop it on the storyboard. Every picture, the default time is 3 seconds. If you want to change the time, then you go to duration. Okay, you click on the picture, you go to durations, then you can change it. Okay, if your video is too long, maybe it exceeds the time limit 3 minutes, then you can shorten it by reducing the time, perhaps. But if you have some picture that you think is important, then you can increase the timer. Okay, you can increase the second. Okay, done. First picture, maybe this is your self-intro picture. Okay, you talk about yourself, your name, your class, and then the experiment, the name of the experiment before you begin the practical test. And then the second thing. Okay, the second things, what are you doing? Okay, now maybe you take the first picture. So you put the second picture here. So second picture again is 3 seconds. Okay, it is 3 seconds. So you put a second picture here, 3 seconds, another 3 seconds. So now you can see the total length of the video showing is 6 seconds, right? Okay, now I'm done with the 2 picture. Next, okay, I want to put a video clip now. So I drag the video and then again I put it here. Of course, if you want to change the sequence, you just drag them. Okay, you just drag it to change the sequence of the video and also the picture. So you change the sequence already, and then what next? Okay, now this video, maybe I don't want the whole video. I just want part of it. So I click on the video and then I go to trim. Trim let you cut the video, all right? So you move this circle around until the positions that you want. Let's say, okay, now this is the starting of the video. Okay, so earlier, maybe it's just some preparation. Okay, so you don't want it to comes up in your video. Okay, so you put a circle here, and then after that, what can you do? You put a marker. Okay, this is a marker for the start of the trim. You drag it until it reaches the circle. Then it will stop right here. Okay, and then after that, you play your video. You play, and then it goes. Okay, maybe this is the end of your video. After that, it's some things that you don't need. Okay, you don't want to include in your video. Then you put the ending marker. Okay, the end of the trim marker. You drag it until it stops right here. So this green color bar is where you want to keep. Okay, the gray out zone, the gray out timer is a place that you want to throw away. You want to remove. So now you're satisfied, you're happy. What next? Okay, done. Click done. So now you see the video has been shortened to 2 minutes, 29 seconds. Just now it's 3 minutes. All right, just now it's 3 minutes. Now, what if this video, you want the beginnings and you want the ending, you don't want the middle part. Okay, then you go to a library, project library again, you drag the same video once again. So now you have 2 identical videos. So what are you going to do? You go to the first video. If you want just the beginning, okay, you drag it to the front part, and then you drag the second marker until the points that you want. Okay, so let's say this is the part that you want to keep. Done. Then the second video, you just want the ending. Okay, you click on the second video, you go to trim. Okay, so now you want the ending. Okay, let's say you want it to start from here. Okay, so you drag the marker until it reach this point. So now you keep the ending. Done. So in this case, one video give you the starting, one video give you the ending. Okay, so this the items in project library, you can drag it down multiple times. Okay, it doesn't matter. You can use the same video clip for 10 times, for example. Okay, because why? Because you keep doing mistake, but then you don't want to stop your recording. Okay, you just make a mistake and then you continue without stopping your recording. So in that case, you can trim it by using this method. Okay, you can trim it by using this method. So you just record it, and then after 2 video clip, maybe you want to add one more picture again. So you drag one more picture. Okay, and then you want to add one more video, you drag another video, you put it here. Okay, and then finish. Okay, done. So now you look at the sequence, okay, and then you want to check whether it's correct or not. What can you do? Okay, you go to the right hand side here. Okay, you drag the timer back to 0 and then you play it. Okay, you see it's moving. 3 seconds for the first slide, another 3 seconds for the second slide. Then it will start to record. Okay, it will start recording. So it will keep moving. So now it start recording. Okay, how you edit it? The product. It shows you the product here. All right, it shows you the product. Now, what if now you have a video and you found that you want to add the text there? So let's say you want to add the text in the second video clip, this one. Okay, so you select the video, you go to text. So it comes out a panel like this. All right. So let's say you want to add the text at the first second. So you drag until the first second. Okay, now you can key in the text here. So enter your text. So testing. Okay, so it comes up. Okay, this is not a good idea because my screen is okay, cannot see it on my screen. I want to place it here. Now it comes up. Okay, you can change the position. You can put it at the middle. You can put it on top. You can put it on the panels on here. So it's up to you where you want to put it. Okay, so testing. So now you look at the time bars again. Okay, so the testing will last for how long? 1 second. Okay, it'll last for 1 second now. If you think this 1 second is too long, then you can reduce it. Okay, you can reduce it. So it depends how you want to edit it. Okay, how you want to change it. The duration. Right? So let's say now is the second time. Okay, now you want to add one more time. Okay, so add it again. Okay, so maybe you didn't add one more times. So you just do it again. Okay, you just do it again. So once you're happy, you're done. Okay, then you just click done. Right? So the works will comes out in the video when you watch it. So just now I edit at where? No. Okay, I don't want to play it, okay, because this is video for other project. But as you can see now, I have a testing here. Okay, I have a testing here. So testing, now it comes out as text in my video clip. So after you watch everything, so you're happy with it. Okay, now I want to remind you one thing. You don't add any effect to your video, okay? Don't give me all those fancy effect. Okay, that is not needed. Even if you put effect, no extra marks will be given. Okay, tak ada markah yang diberi kepada effect. So you don't need to add background music. You don't need to do all the fancy effects, such as maybe the slide pop out from left hand side one, right hand side one, and all those things. No, okay, don't need to do all those effects. Just give me the things that I want. So what is the things that I want? I will tell you after this. Okay, let us finish this video first. So now you watch the video 3 minutes maximum. Okay, from 0 until 3 minutes, you are happy, you are satisfied. Okay, then you go to finish video. Finish video. Okay, now there are 3 types of quality that you can choose. Go for low quality. Okay, even though it say low quality, but the quality is very nice. It's the video, YouTube video that you have right now. Okay, all the YouTube video I use low quality. So just use low quality. Okay, to produce the video. Now, why don't go for high quality? First is data consumption. If you want to upload it to the Google Classroom. The second thing, high quality, HD quality, it takes forever to process. According to my past experience, okay, I once processed a 1-hour video. It took 6 hours to process the video. Okay, because I want it in HD. So it took 6 hours altogether. And not just that, because I process it in a high quality, when I upload it, the file is very large. It takes another 6 hours for me to upload it to YouTube. All right. So don't go for HD. Okay. HD is a huge trouble in an educational field. So we go for lowest file size, smallest file size. Other than having to save data, it saves a lot of time. Okay. Then you just export. So when you click export, it will ask you where you want to save it. Okay. So you just choose the positions that you want to save it, and then upload it to Google Classroom. All right. So this time you need to have two things, okay, 2 assignments to upload. One is a report and another one is video. I give you the times until Sunday night. All right. You have 1 full week to do a video on this experiment. Okay. So practice, see whether you can make the nice video or not. See whether you can have everything within that 3 minutes. All right, this is a test run. So I will tell you where is the mistake, where is the things that you are missing in your video. Okay, so we tried it out. Okay, now let's look at the things that I want you to have in your video. Okay, so this is the things that I want you to include in your video. First thing, you set up the apparatus of the experiment. Okay, so what does it mean? You need to take a nice looking photo. Okay, nice picture of your setup, from the protractors until the pendulums. Okay, and then show me how you will set them up, especially at the point, the one that I told you just now, the starting point of your string. Okay, the starting point is usually where the students make mistake. So I want to see all those details. You can put it in a picture forms. Okay, you can put it in a video form. It's up to you. All right. And then second part, measures and record the length of the thread. You also have to show me how you record the length. Okay, it's from the starting point, the place that you tie the string until the pendulum. So this one you need to show it clearly. All right, you need to show it clearly, and then show me how you record your data, which is the table. Okay. So you can show it again in a picture, or you can show it with a video. All right, but picture usually is a time saving. So show clearly how the measurement has been taken. I want to see how you measured at 40 cm. And then angles of oscillation. Okay, you need to show me before you release it. I want to see that it is less than 10 degrees. Again, it can be shown in a picture. Okay, you show in the picture here. Okay, and then here got a typo. It should be 10 complete oscillation. So this one must be video. Okay, the moment you release the pendulum, you let it swing 2 times, and then you start to count. Okay, 1, 2, 3, 4 until 10 oscillation. Then you stop. Okay, so from the starting, from the moment you start the stopwatch until you press the stop button, I want to see the whole video clip. So this one must be video. Okay, this one must be video, because it shows the process, how you take the reading, whether you do the correct counting or not. All right, so this one must be a video, but you don't have to do for all length. Yeah, you just need to do it for 40 cm length. Okay, 40 cm length. Don't do for all length. And then measure and record the time. You just show me the picture of your phone, because I want to see after you press the stop button, you show me the timer. Okay, you can show in video, of course, or you can show in a picture, because I want to see whether you get the correct decimal places or not. Okay, and then safety. Safety, of course, it refers to the position. Okay, to the place, to the location. So for example, don't do it beside your mom when your mom is cooking. Then that is not safe. Okay, jangan mak kamu sambil goreng ayam, kamu berdiri di tepi buat eksperimen, and then I can see the ayam goreng beside you. Okay, no. All right, so you try to find a safe place. Okay, well, you can still use kitchen. Saya tak kata tak boleh. Okay, just make sure nobody is cooking when you are doing the experiment. All right, so you must conduct in a safe environment. And then last, the cleanliness. So how to make sure that it's clean? After you finish the experiment, okay, you show the pictures of the surrounding. Okay, you show me the pictures of your surrounding. You take the maybe a few picture, or you can use a recording to show that you're done. Okay, now you remove the apparatus. The apparatus is one side, and then the place is clean. You clean up the place after you do the experiment. So 7 things that you need to include in your video. Okay, that is the 7 things that I want to see in your video. If you can do all these 7 things, then you can get 21 marks from me. All right. So each category got 3 marks. So if I'm not satisfied, maybe I will minus 1 mark. If I'm very unsatisfied, then I will deduct 2 marks. Or if even worse, I give you 0 marks straight away for that category. Okay. So try to score maximum score here. So this is a test run. I want to see whether you got a skill or not. See whether you know how to do the recording or not. All right. So any questions? Yeah. So far, any questions?
No, madam.
Okay. Tahu buat video kan? So for those of you, because I think our students tell me they don't have laptop. If you don't have laptop, then you have to use this week try to search, see if there is any phone software that allows you to do all this editing or not. And make sure if you use all those software and it got watermarks, make sure it don't cover up the important informations in your video clip. Okay, that's why I want to do a test run this week. I want to see whether you know how to do it or not before we start our practical test in I think next week or the next week. Okay, the coming 2 weeks. All right, now if no questions, I think that's all for today. Okay, so you may leave the class now.
Thank you, madam.
Thank you, madam.
Thank you, madam.
Thank you, madam.
Thank you, madam.